Hello and welcome to my channel. I decided I spent the day taking pictures and videos and decided I would share a day that we experience now in today's world rather than something we never saw more than 10 years ago, ever, in my lifetime at least, of 43 years of mostly paying attention to the sky, even though I did miss the moon for a few years. But through my childhood, I did see a few things, and like I've seen a halo back in the early 80s, a sun halo, and it was white and very small compared to what we see now. But this this picture here was this is just before 7 a.m. The colors are completely new to us now. Sure, there are sayings like red skies and sailors, everyone knows it. But I mean, the sailors have got to be getting emotional, whiplash at this point with red sunrises and red sunsets almost every day. Okay, so, you know, about 10, not well, about 5 minutes later, it progressed to this. Another wider shot at the same time. But I want to point out another thing that we didn't see here is you can slightly see what looks like ocean waves, or you'll see waves in sand that's windswept, wind blowing across water. Y'all have some better examples in this video. But these are several things, pinks, reds, purples. These are all new and comparative to, well, even my lifetime. We'll just say in the last 50 years. Because many of my subscribers are the same age as me or slightly younger. And they will agree they never saw things like this either. So it's safe to say our grandparents or great-grandparents didn't either. Because they would not recognize the skies we have today. Especially with something like this. And yeah, this happened in the past on rare occasion. But this is an almost everyday occurrence. Alright, so I do have some videos of that same time. These are like 10 seconds each. Let me pause that. So obviously we're facing east. And we're panning around, and all kinds of things that we see in the clouds, cloud formations that we've never seen before. I'll get to those. You'll see I've even got a little better one. But this is a video basically of what you just saw in the last few pictures. Alright, so let's go to, this is about, oh, I'm sorry, wrong. It was this one next. This is about 30 minutes later, panning the same way. As you can see, those ripples or waves are much more prominent now. Much more clear to see. We have some blue sky peeking through. Have you ever seen things like that in water or sand? Or now we see it in the clouds. Never until now. Okay, so here we have a little later on, about 30 minutes. We even got some what they call Kelvin-Helmholtz cloud formations. I've captured that many times. More wave clouds, more cloud formations I've never seen until the last few years. Very interesting. All energy flow. All right, so let's go back to. They were at the very beginning. There you go. Kelvin-Helmholtz coined that term for these, is like waves, capping ocean waves, but it's still energy flow. The field line in this case is actually coming around like that, tipping in, and then it comes right back out and goes down. So it's curls in and goes around and back on out. Neat. This is horizontal field lines, the clear areas where the clouds, obviously these are slightly covered, but you can still see the field lines are straight through here and the energy is flowing this way. Alright, so as the day progressed, I got some pictures. Yes, this was sprayed, but let's get a little closer in. As you can see, as it was sprayed, it's swirling. I mean, this is long after, we all seen the pictures of when they spray and how they curl, but this is long after. It's still spinning. The double helix formation, perpendicular flow to the outside. I have a better example of that next. Here we go. Okay. Main area of energy flow, double helix, so like a DNA with perpendicular flow out to the sides. In this case, the clouds were flowing this way, the airflow, but why, this is into, these ones over here, into the wind, so you can't say these are all wind swept clouds, or these clouds are formed by wind. These are formed by energy flow, because energy moves matter. Do you want to learn that? You go to Scientific Lee's channel, the playlist, a field in motion, something define. I'm having a brain fart on it right now. Scientific Lee playlists. Okay, this is a little later on. Let's go back to. Okay, so this is in the evening. We have the same types of formations. Wave clouds, waves formed by energy flow. Let's see. Now, a lot of these pictures at this point were taken through a windshield. So if you see spheres and orbs and things, that's the windshield. No pictures am I showing here are a planet. Okay. When this was sprayed, obviously this was and this was, but it doesn't matter sprayed or natural, they all still are regulated by the same energy laws. And why we didn't see formations like this 10 years ago, even though it's only been about 3 years for something like these wave clouds and these formations, it's because the energy in the Earth's atmosphere is increasing. So we are seeing more magnetic fields. So therefore the clouds are showing them. Like the atmosphere is saturated rather than before it wasn't. So the clouds did not show these formations. It's just showing a different formation. These are kind of like they explode. A perpendicular motion out of a central motion. And like I was driving in these pictures, so I had to take them quickly. But this is a really good one, interesting, that blows the whole wind-blown theory out of it. Is perpendicular motion outside the main double helix flow. The wind, let's see, yesterday, this is heading west. Our weather is coming from the south, so the wind was blowing this way to the right, slightly from the top down to the towards the right. So this perpendicular flow out to the side. So it's not windswept. Okay, so let me I have this picture. Let me show this. This is an older picture I've used. This is the sun halo. It's a magnetic field. Uh, the energy is crossing an inertial plane, so therefore we see the pieces of the magnetic field. Impulsion V. This is the inertial plane. Inertial plane. That's why we see the sun dogs, because the energy in the magnetic field is coming around and into the inertial planes. And from the bottom, the field does not reciprocate. That's other videos. But I just wanted to show you what these next two pictures, what this is right here. This is a piece of that. This is, let me just move that. Oops, not over there on that monitor. Let me shrink this one down. Oh. There. No. Well, you saw the sun's over here. This is the sun, what people call the sun dog. So you see the same halo around the moon. It's same concept. They have what sun dogs on the moon is called, what people call, you could call them moon dogs, because if this is a sun dog, that's a moon dog. In fact, here is a moon halo with the same formations. So it's a magnetic field. Okay. So, and then a few minutes later, as I was continuing, we saw the other side. The sun is over here, and then we see the other. We just can't see all of the halo, but this is the same point. Inertial plane, and what people, bunny ear quotes in the air, sun dog. Well, it's not, but I'm sure there's somebody out there who saw this. Oh, it's a second light source. No, it's just this. That's it. Still something that never happened. I saw it once in my childhood, a small halo. Okay, we'll do a comparison to this halo. The halo I saw as a child was this big. And it was all white, no formations, just straight halo. So it was much smaller. Okay, let's see. We got through the morning, we got through the afternoon. And then we have an evening. I talked about some of these formations I'd show later. Well, this is the video I was waiting for, because it's pretty clear what I mean by wave clouds or wave formations in the clouds. As the sun had set, this is evening, they became very apparent with the contrast of light and dark. You'll see this all day long if you have clouds at some point. Even in the lower levels, lower level clouds, it's like larger waves. Higher, they're smaller, tighter waves. Okay, so now I have the next three videos, which are very important, but it's also a change that is new in comparison in the last 10 years. And that is the moon. Here we have, I took a little video just to show that it's a legit video. Nothing rotated, and my son's going to come down and get noisy. Okay, so you saw that. Well, let's just make it big. Let's go over it again. Okay, you see the moon position. It's a waxing crescent. Not quite gibbous. Gibbous is when it's first quarter to full moon. That's when the gibbous part comes in. Alright, so if you were to connect these 2 points of the crescent and face that on a clock face, we're looking at, say, 10 p.m. and 4 p.m., right? Well, let's go to the next video. Let's look up those times. I don't the times. I have it open on my phone. Okay, the first one, the video was at 1 p.m. This video was at 5:50 p.m. So we're looking, we'll just say 6 p.m. So we're looking at 5 hours later. And I just want to check my last video was 8:15. So 1 p.m., 6 p.m., and 8 p.m. You'll see in the next video. Here if we connect in a line from the tips, well, now we're over here at 2 p.m. and 7 p.m. or 8 p.m. 2 and 8. We were at 10 and 4. Now we're at 2 and 8. Okay, well, here's video number 3. This is 8 p.m. And we have the Cheshire cat grin phase. Basically, it's basically 3 and 9. If I had done another video an hour later, it would have been 3 and 9. So we went from 10 o'clock to 3. So we're looking at 90 plus another 30. So we're looking at almost 120 degrees. Here, and then, but at this point, we see the moon more during the day. At this point, it's going to be, it sets kind of early in the night. So as time progresses here in the next week, we're going to see the moon more at night until full moon, and then we see it's equal 12 hours. It rises at sunset, sets at sunrise, and then we'll start seeing it only during the day. Or, I mean, at night, and then only a few hours before the sun comes up. So it's normal for the moon to, right now, we view it more during the day and less at night, and then it's more and more at night, and then it'll become after full moon less at night. We won't see it at all until after new moon, and then we start seeing it in the afternoon again, like we are right now. Okay? So don't give me this is normal. There's hemisphere-specific views, wax and wane. This is an equatorial view of the moon in my Virginia. In Virginia, this is impossible, and the only way this could happen is if I flew from Virginia to the equator. That's the only way this could happen. So I suggest you look that up. You could start that with if your new Lunar Phase Wiki page will be enough, because it'll teach you about hemisphere-specific views, wax and wane. It doesn't say anything about a cartwheeling moon that should change hourly from our perception here on Earth. Okay, so that is basically everything that I see that I never saw until at a minimum 10 years ago, or maximum 10 years ago, because the moon started rolling 10 years ago, and I didn't see it until about 3 years ago. So we could say all this is something that most people have been seeing for the last 3 years, only up to 10. And I'm just going to throw this one in here. So this is a picture I took a while ago over the summer. You have to break the glass to get to the key to get out of the locked fence. What are you going to do? Quite a conundrum, huh? All right. I will talk to you all later. Bye.